So now in this video, we're going to set the current, in this case through an LED, that's our load, with a NPN Bipolar Junction Transistor wired as a current source. So of course we're going to need more than about 2 volts before the LED will start glowing, but a little bit above that, there you can see it's starting to get brighter as we raise the voltage of the trim pot. Somewhere around here it's probably going to get to its max brightest. But in case, we can actually set the current if we know the voltage. So this is 12 volts. If I set this to about 6.6 volts, because it's a voltage divider, then we should have about 6 volts across this 1000 ohm resistor. So we probably got about 6 milliamps of current going through the LED transistor and the 1 kilo ohm resistor. So now I swapped that jumper for this jumper right there, so I can easily plug this and we can take a current measurement later on. There's the power supply though. As I said before, we're using 12 volts and somewhere around 6 milliamps of current should be flowing through the load. There's also some other current. Since we got 12 volts, probably about 1 milliamp of current is actually going through the voltage divider right here. Plus some is trickling that way and whatnot. But the power supply also is not as accurate as a multimeter. So first off, let's take a look at the voltage we're getting to the base of the transistor. So I could probably just use a jumper right there. Maybe I had a problem instead of a resistor. Okay, so I was shooting for 6.6, but that's close enough. So we should have about 6 volts. 6.1 actually makes more sense across this 1 kilo ohm resistor. I was at the emitter, but it's the same as measuring that resistor directly. So if I want to really try to get 6 volts across here, I can be measuring this, and then if I can get a good grip on the two, and then just slowly turn this down until we got 6 volts across it. And I think this might be as close as I can get. There we go, 6 volts across there. And it's going to be probably just a speck above 6.6 there. Okay, so we got our load. Now I'm going to plug this, and we can actually measure how much current's going through the load. We need an open gap though to do so. So I don't put this on measuring current until right before I'm going to measure current. I don't have to move the red probe for anything but the amp range. I think we can measure up to 0.6 amps with this, just in the milliamp setting, 600 milliamps. So we're going to come up here, and there you can see, pretty close to spot on 6 milliamps. It says milliamps down there. And we can go to the emitter, we can bypass the transistor, and it's going to be the same current. It's a current source. It doesn't matter what the load is, although you need more supply voltage as you get a load that needs more voltage, of course. You know, basic current source stuff. So I'm going to get this definitely off of measuring current, but we're all done with it. We can turn it off completely. So you got to bridge the gap if you're measuring current. Obviously, if you want a circuit that works, you can't have gaps. So I'll put the jumper back, and we will light the LED. But again, we, you know, within limits, because the red LED drops a couple volts, so there is the potential for not being able to get the full supply voltage across that resistor plus the transistor or whatever. But yeah, we could go to like 4.6 volts, and then we'd have 4 volts across the 1 kilo ohm resistor and 4 milliamps of current flowing through there. We can, you know, set it however we want. It's an adjustable current source with some limitations, but for the most part, whatever voltage we get across here, for each volt there'll be 1 milliamp of current. But you always got to remember that base to emitter 0.6 volt drop, and there's ways around that. You could use an op amp, although they usually can't provide as much current as a transistor, but when you're working with LEDs, you probably get enough from the op amp, most of them. And if I put this all the way to power supply, it may help to have that resistor. What I'm thinking is that you'll get so much current over this way that the transistor won't provide current through the load. So I think that's why I need that 1 kilo ohm right there. So, you know, this should not affect the voltage at the base really, because the base to emitter needs so little current. But if you don't limit current, it could also just rush in, and then the transistor has no reason, because the voltage will build up here from the signal. So it would cut off the collector. I'm pretty sure that's why I added that. I probably tried it without that resistor. But in any case, that's why you experiment. We can go all the way to the positive supply. Even if we don't have the resistor, it's not a short circuit. So you can try it, and if your circuit works, you know, that's good. But if it doesn't work, you know, you didn't damage anything, and you got to figure out why it didn't work and learn from it. And so I did that a while ago, and I'm assuming that's what I learned. But I don't see any benefit to trying to short it right now. I made this diagram a long time ago, and you know, I probably made it the way I made it for a reason. But in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.